Arnav from Team Bite My Car. This is Park Watch, Bengaluru Parking Enforcement Intelligence. My submission for Theme 1 of the Gridlock Hackathon. BTP collects almost 3 lakh violation records in 5 months. The problem isn't data, it's that BTP can't see the patterns inside it or act on them in real time. Park Watch fixes both. BTP's brief flag 3 things. Enforcement is reactive, there's no heat map of violations versus congestion, and zone priority is unclear. I built 4 analytical modules to address each, combined into one dashboard. Before I explain the modules, look at this chart. These are the hours when BTP books violations. Tall bars all morning, peaking around 10 to 11 am. After 2 pm, the chart falls off a cliff. By 3 pm, it's near zero. At 7 pm, across 5 entire months, only 27 violations were booked in all of Bengaluru. 27. That's not because illegal parking stops, that's because officers go home. BTP is structurally blind for roughly 12 hours every single day. This gap is the operational insight ParkWatch is built around. The rest of the system, cost quantification, forecasting, patrol routing, all exist to close it. First question, what does this cost the city? For each of the 381 hotspots that my DBScan clustering identified, I snapped to the nearest road segment using OpenStreetMap and pulled the real lane count. Then I apply the BPR delay function, the standard equation used by every transport planning authority in the world. When capacity drops because a lane is blocked by illegal parking, delay grows non-linearly. Computed across the 100 hotspots, which together cover over 90% of all violations, the city loses Rs 389 crore a year. That's roughly 10% of Bengaluru's total congestion bill, attributable to just 100 parking zones. The single biggest one, Kyar Market Junction in Aprapret, costs Rs 16 crores on its own. And every assumption in this calculation, dwell time, value of time, lane capacity, is an explicit defensible now. Next, I built a forecasting model that predicts where violations will happen during the blind spot. XGBoost regression on 1.38 million hourly observations. The features cover calendar effects, recent activity lags, geographic location, vehicle mix, and an annual seasonality layer that learns festival, monsoon, and holiday patterns. Diwali week is structurally different from a normal week in KR market, the model that picks up. Recent data is weighted higher via 90-day exponential decay, so as patrol patterns shift, the model adapts. Strict chronological train, validation, and test split with early stopping at iteration 54. The held out test R squared is 0.43, visible right here on the dashboard. The train to test gap is just 0.07, well below the overfit threshold. Importantly, the test set actually performs slightly better than validation, which tells me the model generalizes, it isn't memorizing. What does the forecast tell us? Across the top 100 hotspots, roughly 743 illegal parking incidents will go unbooked in the next 24 hours, unless something changes. One honest caveat, the dataset captures bookings, not every event. A 1 week BTP pilot would validate the forecast in the wild. So I converted the forecast into action. Weighted K means assigns hotspots across 5 patrols, balanced by expected catches. Within each patrol, nearest neighbor TSP minimizes travel time at 20 km per hour, with 15 minutes of service time per stop. Note, 5 patrols is a demo scenario. The optimizer is parameterized, so in deployment, BT would provide their actual nightly fleet size and the route scale to match. The output for tonight's evening shift, 53 optimized stops across the 5 patrols, roughly 96 expected catches in total. That's about 3.8 times what BTP catches today, with the same officers and the same 5-hour shift. Each patrol also gets a per office shift sheet, printable, downloadable, and sendable on WhatsApp. Watch what happens as I mark next stop complete. The remaining route resequences from the current position. ETAs update live, and if the replanned route runs past shift end, the system flags which low value stop to drop. That's real-time adaptive routing working in V1 today. Below it sits the hotspot priority lists. 381 zones, ranked with the responsible police station, BTP junction code, dominant vehicle type, time of day share, and the actual address. Every prediction is interrogable, no black box. Park Watch is the intelligence layer that closes Bengaluru's 12-hour enforcement blind spot. It runs on the data BTP already collects, no new sensors and no new cameras, and every officer keeps doing what they already do. just smarter. Park Watch Park Watch doesn't replace patrols. It makes them predictive instead of reactive, which is the actual gap the brief names. And the system gets better with use. Daily incremental updates, weekly full retrain on a rolling 6-month window, Hots- monthly hotspot reclustering. Park Watch bootstraps as the patrol patterns expand. The V1 already routes adaptively per officer with live replanning. V2 adds personalized learning over time. Thank you.